Good morning, everyone. I am Shivam Kumar Pasu, BTech CSC with specialization AI and DE in Learning Professional University, and today I am going to explain web browser navigation using doubly linked list. So first of all, let's understand what is a doubly linked list. So basically, a doubly linked list is a different from the single linked list in a way that each node has an extra pointer. Means in a single linked we have only two pointer with only having a forward node. And but in the doubling list, we have an extra pointer that points to the previous node also, together with the next pointer and data similar to the single linked list, like null data and next, then the next pointing to the next node. And but in a double linked list, we also have a previous node which is for the pointing to the previous node. We have next data next for pointing to the next node, but the second node has also pointing to the previous node. We got the ability to the move backward. In this W linked list, we have the ability to move backward. Like in this linked list, we in this node, we in data next and the previous node is pointing to the next, which means we can also move backward and which can also move to the forward node. So in our example, like we are taking a web browser navigation. We have a example like example.com. We've forwarded to the next website with google.com. Then we visited to the next website, uh, facebook.com. Then next to the stackover.com. But in our linked list, we can also move back to the next facebook.com. So we are in a facebook.com. We are in a facebook.com, but we can check the back history like we are in a Facebook. If we are moving backward, we will go to the google.com. Then we will again move back to the next node, we will move to the example.com. But what is our forward? We are next in a currently in a Facebook. What is our forward website? That is the forward history we are having stackover.flow.com. So we are having this W linked list web browser navigation with the same thing we will implement in our code. So now let's begin with the code for implementing our web browser navigation using W linked list. For that, we will use Python language. So let's take our class page node. Then we will define init function, which will take two input self and the URL, in which self dot URL equals to URL in the self previous node equals to none. Then the self next node equals to none. Then we will take another class for browsing history. Browser history will define a init function, take input self home page history, history limit, how many times the website have been searched. Then we will take the self home page. Self current page. Current page equals to the page node which we are presently at. Then the self for the browser history, self.history, home page. Then if we want to bookmark any website or a page that we are in, we will take self dot book bookmarks equals to set. Then the self dot history limit equals to history limit. Then we will define the widget node. We define the functions for the visiting the next node. Or we can say the next page. If we have visited further Facebook. For that visiting node function will define if visit taken to self and the URL the new page for that new page equals page node. Page node with the URL. Taking into new URL, new page, dot if you are moving back to the previous page, so equals the current page self and self dot current page dot next equals to the new page. If we are in the current page, then if we are moving to the next page, then we are into the next page of the current page. Then again self dot current page equals to the new page. Then print visited equals to URL. So if we have visited to the next page, here, then we need to go to the previous page or find the function just that taking into self. So if self dot current current page dot previous is not enough, then self dot undo step. When the back page self dot current page dot URL Then self dot current page equals self dot current page dot previous. Remove that. Now, print that page, print back to the current page dot URL, or else we can say we have to have any previous page. For that, if we are not having any previous page, print no previous page. Then if we want to print a forward page that will discuss the Facebook page for that one is the browser is the forward function, forward self will take going forward to the next page. Take self dot parent current page dot next is not the if that is not then we have any next page for self dot and we will stop the print maybe the next page for forward self dot current page dot URL self dot current page self dot current page dot next. Then we print the forward page, forward to which page we have forwarded, self dot current page. Else, we don't, we have not visited to any next page. So for that, we will print no forward pages. We have not visited to any next pages. Then for displaying the history of the web browser, we will give function display history. Is to take into account. So displaying for displaying history will display all the web pages that we have visited. Print browsing history for file URL in enumerate self display Print permission v plus one dot border. For example, if you want to browse the browser equals browser history, we have visited Google first, google.com history limit plus 3 browser. If you're visiting, first of time we have visited Facebook, then we visited the next browser, YouTube. Then we have again visited the next browser that is TikTok. Then we have visited the three websites, Facebook, YouTube, and Twitter. Then for displaying the all the visited sites, we will display browser dot display browser history, then browser dot control. Here we have displaying all the browser history. Then we will add the Twitter. We will have add Twitter. Then browser dot backpage to the website. So now let's check and run the code. This is the code. So here you can see the visited website. Whatever the website we have visited, like we have visited first facebook.com, so here we have facebook.com, next YouTube, and then YouTube, and the third, and the friendship at Twitter. We are finally at a Twitter. Now the browsing history. Which website or the site we have visited, that is a Google. The browsing history we are at Google, and then and we were able in Twitter to we are moving to the YouTube. So here we can see back to youtube.com. But in the browsing history in the particular Google, whatever of the site that we have visited, like Facebook, YouTube, and Twitter, we want to show the result in this browsing history. Let's add some codes for it, like we can add in the visited website, whatever site that we have visited, we want to show them in our history. So we will add twist. Not if we are not using incognito mode, then we can only show the browsing history. If we are using incognito mode, the browsing history the site will not be shown. So for self, incognito mode is not there. If not, self dot incognito mode, self dot history dot append URL if length of the history is self dot history history limit self dot history dot pop 0 then self dot undo stack undo stack dot. Then the visited website that we have mentioned is the result of that URL. Now here only we're having Google. Now we'll have all the site under the Google that we have mentioned, like Facebook, YouTube, and Twitter. So here you can see in the browsing history we have visited Facebook, we have also visited YouTube, and we also visited Twitter. Earlier it was only shown the site that is Google. We only visited to the Google, but now under the browsing history, all the sites that we visited are Facebook, YouTube, and Twitter. Currently, in the last state we are at twitter.com, but we have done the browser dot back. We are moving because of the bulking. We can move forward as well as backward. So we are moving backward, go back to the youtube.com from the twitter.com. Another thing we can add in our code is like if we are using incognito mode for browsing anything like Twitter, Facebook, that will come in our browsing history or not. So let's check that. We write code over there, this function, toggle function, incognito, incognito, taking input, self, self, incognito mode equals not self dot incognito mode, then mode equals. If the mode is on, then if the self dot incognito mode is on, incognito else if that is on, then print mode. Then undo the last action. If the incognito mode is on, it means the last for that function undo last action taking into self if not undo start stack, then print that we have no actions undo return return back to the or article self dot stack out if action equals to widget. If we are visiting any site, randomly we go back to the previous page. If self dot current page now preview is not the self dot current self dot current page equals self dot current page dot preview. Then print 100 reset back to self dot current page URL. If if action equals to action equals to back means to go forward. So self dot forward. Self dot forward or if action equals to forward here undo forward equals to move backward. Then if we want to bookmark any visited page, what are we look at function bookmark a page bookmark the current page or self dot bookmark dot h self dot current page dot URL. Then print the bookmark page bookmark code URL self dot print URL. Print dot URL. In the system, we have informative and the bookmark browser dot browser browser dot bookmark page browser dot incognito incognito page browser dot the visited page incognito, incognito.com, limited incognito, but in the browser history, this incognito will not be shown. Let's see how. So, browser dot display history, the browser dot undo, the last action, browser display the bookmark, display the bookmarks. Again, now, so finally we are done with the code. Now let's check the code again. So here comes our output. Like first we have visited Facebook, we have Facebook, then YouTube, then last we visited with Twitter. The browsing history is like Facebook first, then YouTube, then Twitter, then we were back to the YouTube. Had continued Twitter, we back to the YouTube. At that time we marked to YouTube. Then at that time we ignored incognito mode was on. We visited incognito mode. Then after visiting to the incognito mode, we have the browser history again. In incognito mode, whatever thing that we do, that doesn't come in our browsing history. So in the browsing history, we have the same output, Facebook, YouTube, and Twitter, but we don't have the incognito mode because the incognito mode comes in the browsing history. So until visit, we were back from incognito mode, we're back to the YouTube. So the bookmark pages is the youtube.com. We have the bookmark page, YouTube. So basically, this was our the web browser navigation using the doubly linked list. So this is the code. Moving on further now, let's calculate the time and space density about code. So here for a class page node, like class page node depth and its function, the space complexity. For each page node, we are storing three things like URL and the 2 pointer page and the next next function. So each node takes a fixed amount of space. Each node takes a fixed amount of space, regardless of how many other nodes are there. So for one page node, where the time complexity is big O of n. For one that single particular page node, that space complexity is big O of n. If there are n nodes, so if there are n nodes, that is n pages visited that we have visited previous and that we have visited there as Facebook, Twitter, and YouTube. The space complexity by all the nodes is big O of n. The times of the nodes are there, the space complexity is big O of n. Moving on further, the visit function, the time complexity. If we are creating a new page node, takes big of one time. Setting the preview and the next pointer of take only big of one constant time because we are just adjusting the link between the two nodes. Appending the history takes also big of one. The total time complexity, each operation inside the function take consistent time. The overall time complexity of the visit is big O f n. Then the space complexity. After n visit, we will have n nodes. So the space complexity for the storing all the these nodes is also big O f n. Now for the back function, like f back cell for the time complexity. Moving on to the current page, we are moving to the current page, the pointer to the previous page, a simple pointer chain, which takes only one step so that time complexity of is we go of one time consistent regardless of how many pages are in there in the list. So total time complexity of the is big of n for the back function, but the space complexity, no new space is used when going back. So we are going back. There is no space used. So the time complexity remains the same. That is big over and next the forward function moving forward to the next page. Moving the current page, the pointer to the next page takes only big of one time. So total time complexity is big of one. So if we are moving any additional space or moving forward, there is no space used. So the time complexity is big of one and also the same as the space complexity is also big of one. Displaying the history. For displaying history, the time complexity, if there are L times in the history list, then the loop will run L time. If there are L times items, then that loop will also run L times. When each time takes consistent one. So for one time it's take big of one, for the L time it will take big of L, where L is the number of the entries in the history. So time complexity is big of L. The space complexity. The history list takes L space proportional to the number of the URLs stored. L stored URLs are stored, so the space complexity for the list is also big of L. If there is a history limit, the space complexity is zero history limit. But if isn't there is big of L. If we are setting a history limit like we have history limit of 3, then the space complexity will be big O of 3. Or the number of times the history limit is set, the space complexity will be that only. Undo last action. So time complexity, copying an action from the undo stack. Copying an action from the undo stack, we are moving back to the previous node. It will take only one step, so the people of one are always consistent. Moving current back to the previous step, it was not his before and so the total time complexity for the undo last action will be V over n. Now the space complexity. Space complexity undo stack grows as you perform more actions and each action takes big of n space. So the number of action we will perform, that space complexity will be big of n. So the conclusion is for the time and space complexity for a particular code is that the time and space complexity depend on the nature of the operation and how many scale with the number of items like nodes, URL, bookmarks. It will depend on the number of items, number of scale, how many times we have visited the page or the action we have performed. If we have performed in actions, the space complexity will be L. If we have moved back to the visited one page, the time will be of one. Like visiting a page, time complexity one, back navigation, big of one, forward navigation, big of n, displaying history will become the limit. Number of the L times we are visiting the big of one node or the history limit. For the incognito mode, we have visited only one time. Just using the Boolean flag is big of n. Like creating a link out, move one step back in the list, move one step back in the list, move through the list, just with a Boolean flag, and to the last action, performs the undo stack and move back for bookmark page, insert a page into the bookmark set, the bookmark, we go up and loop through all the bookmarks. So this was all about the space and the time complexity of our particular code like web browser navigation to the domain linked list. So this was all about the topic navigation browser to domain linked list. So thank you.